In stats, we wrapped up chi-squared testing notes, and I was a page too far. So we are looking at test number 2 of chi-squared, and that's the homogeneity test. You're testing to see if one variable is the same for another variable in regards to individual proportions. So this at the very top that I typed right here tells you it's homogeneity. So if you have multiple samples taken, that is a homogeneity test. Indicator of homogeneity. And you'll see in the next test, I'm out of room, barely fit that. You have one sample for independence. Another thing, this is a two-way test, meaning use a matrix to run the test. So you want to create a matrix, I'll show you how to do that, and store that matrix, and then run the chi-squared two-way test. All right, let's dive in. We have political party and cell phone usage. This right here, separate random samples of cell phone type were taken. That tells you homogeneity. If they just found some central location and asked random people about cell phones or phone usage and political party, then it becomes an independence test. All right, HO will be for people under 30. They're kind of vague on that. Proportions of political party. There's a few ways you could word this. Are the same for type of phone used. Another question people have is, what is your null hypothesis? Well, since the name of the test is homogeneity, that's your null. So maybe back up at the top of the page, add another note. Name of test should match the null. So since homogeneity is implying sameness, you want to use the word same in your null hypothesis. HA, just say they are different. Keep it easy. Keep it simple. You already defined the groups and the variables. Set alpha, or they gave it to us, 05. They took independent random samples. If you wrote separate random samples, that's fine. The other requirement is that expected values are greater than 5. So remember, proportions, you have the large counts, NP greater than 10, N1 minus P greater than 10. Means, it's got to be greater than 30. For chi-squared, they have to be greater than 5, the expected values. At the top of the page, it tells you how to calculate these, but the calculator does it for you. So I'm just going to make a blank space here, and I'm going to make an assumption that they are greater than 5, and move on. I'm going to run the test. The calculator will calculate the expected values for me, and we'll go from there. So hopefully the blank space stands out to us at the end and we don't forget. So I do that on purpose so that we don't forget. All right, this is a chi-squared homogeneity test. And then grab your calculator and create a matrix. So I'm going to take these 6 numbers, ignore the totals, and I'm going to create a matrix. So I do it, I think this is the fastest way. I don't know, maybe you have a better way. I press the button next to the 9, see where it's red? And then the shaded button right here, the shaded option, is the customize button. So you press that, and we have 3 rows. I use the tab key to go between the cells because if you press down, it's going to change what you typed. So tab, and then we have 2 columns, tab, okay. And then I type in my data. We had 49, 15, 32, 47, 27, and 30. I store the matrix. I think there's other ways to do this, but this is the most efficient way I could find. I press Control var. See how it says stow right above var? And then I pick a letter. I always pick A. And now I can call that matrix anytime it asks for it. So you go to tests. And we want chi-squared two-way test. I named my matrix A. Also notice, I just realized you have another hint right there. Observed matrix. So that's an indicator you want to type in the matrix. Hit OK. And it gives you chi-squared, the p-value, degrees of freedom. We'll get the expected matrix in a moment. Well, let's actually go ahead while we're talking about it. Press var. And if you've done multiple chi-squared tests, you'll have a lot of results here. The EXP, the current one is the one closest to the top, and it is right there, EXP matrix. So hit enter, and there are our expected values. You need to write those into that empty matrix that we made on our paper. All right, let's wrap this one up. So we had 46.1, 20.2, 29.8, 49.9, 21.8, and 32.2. Chi-squared was 3.21, 99, with 2 degrees of freedom. By the way, the formula for that is at the top of the page. You go rows minus 1 times columns minus 1, and that would in this case be 2 times 1, which is 2, but the calculator gives it to you. And our p-value, chi-squared is a positive skewed distribution, so it's always a greater than. And our p-value was 1999, which is greater than alpha. So we fail to reject. Evidence does not suggest. So, phone usage, type of phone usage, whatever, is different for each political party, something like that. For political party, you probably don't even need the word each. For people under 30. And that is a chi-squared homogeneity test.